Okay, in this video we're going to go from vector notation of the magnitude and angle to the x and y components, or the ij vector notation. So let's start with an example problem from the previous. Right, naming vectors. How do we describe or just define where the following vectors are located? So how do I find 12 meters at 27 degrees east of north, 5 newtons at 36 degrees west of south, and 13 meters per second squared at 17 degrees north of west? What I would do is draw a coordinate plane and draw these three vectors in the direction in which you are being told as a little practice. So go ahead and pause the video, draw those. Okay, go ahead and check. Okay, so in this case, make sure if I'm east of north, right, I start north and go to the east. If I'm west of south, I start south and slide to the west. Maybe it helps to draw a little arrow on your vector angle notation. This is north of west because I start west and slide to the north. Okay, so hopefully that'll give you a little practice drawing vectors in the right space, or in the right space on your coordinate system. Okay, let's convert now our vectors from the magnitude direction notation to my xy unit vector notation. So first thing I got to do is I got to draw this vector 12 meters per second. So this is a velocity, because it gives me a specific magnitude and in a specific direction. So let's draw this on my coordinate plane. Always start in the center, and I'm 40 degrees south of east, so I start east and sweep to the south 40 degrees. Now you don't need to use a protractor, just eyeball it, but I do think you need to label it well so you know what you're doing. So the 12 meters per second is the magnitude relative to the length, the 40 degrees is the direction. Now how can I turn this into standard vector notation of my x component and my y component? Well, all we have to do is simply start in the same place and say I can break this into an x part and a y part. And if I start and end in the same spot, right, these are equivalent notations. So how am I going to do this? Well, what we said in the last video is that when I go over and down with my y, I create a 90-degree angle. So now I have a triangle that I could do some 90-degree triangle trig with. So not too tough. I know the hypotenuse here. I know one angle. Therefore, what can I use to find the value of x and the value of y? I could use my sine and my cosine. So ka, right? The TOA will come in with the next one. So I know from a little bit of trig that the sine of 40 degrees is my opposite side over my hypotenuse, my y over 12 meters per second. So my y, multiply by 12 meters per second, both sides, is 12 meters per second times the sine of 40 degrees. Make sure you're on degree mode on your calculator. 12 sine 40. So the magnitude of my y vector is 7.71 meters per second. Now I need to define the direction, and this is in the y direction, so my unit vector is the j vector, and it's going down, so it's negative. So my vector notation for the y component is minus 7.71 meters per second in the j direction. All right, what about my x? Same thing with the cosine. Cosine of 40 degrees is my x component over 12 meters per second, multiplied by 12, multiplied by 12. So I get x is 12 cosine of 40 degrees, 9.19 meters per second. And this is in the positive x direction, so I add my unit vector notation I, which is also positive. So I can say my vector r in vector notation is 9.19 meters per second in the I minus 7.71 meters per second in the J. And that's how we go from magnitude and direction to vector notation with my I component and my J component.